Hello, yeah, in this interesting videos, I just want to show you how to make a graph to illustrate the point that why p less than 0.05 is an arbitrary threshold by creating a visualization in R. So as you know, p less than 0.05 is used as the criteria for determining the so-called statistical significance. Okay, so this is pretty arbitrary, and through this simulation, I want to show it has a flaw. Basically, we can always achieve p less than 0.05 by keep increasing the sample size or increasing the effect size. Okay. So let's get started. So I will need the ggplot2 package, and I'll set up the plot appearance by using the theme set. So theme minimal base size equal to 13. Okay. And I'm going to use the study design. I'm going to use alpha equal to 0.05, and I'm going to create a sample size in each of the two independent groups. So I'm going to use the independent t-test as the hypothesis test. Okay. So true standardized mean difference, which is Cohen's d, a very popular effect size measure. Okay. And d equal the difference in group means divided by common standard deviation. And we can create a d grid from 0 to 0.8 by 0.01. Okay, so now we have created sample size grid. We created the effect size grid. Then we create all sample size effect size combinations using expand.grid command, and just put in the n per group equal to the n grid, Cohen's d equal to d grid. Okay. And then we calculate the power, which is the probability that a two-sided two-sample t-test yields p less than 0.05. And we have assumptions, which is two independent groups, equal group sizes, common standard deviation equal to 1, and two-sided t-test. So we can use this mPly function to calculate the grid probability p less than 0.5. M apply to functions of n and d using the power dot t-test, n equal to n delta equal to d, s d equal to 1, significance level equal to alpha, power equal to null. We want to use the generous sample size, right? No, the probability, we not generate probability of p less than 0.05. So two sample, and the alternative is a two-sided and strictly equal to true, and we get the power, and we assign n and d equal to grid at n per group, d equal to grid at Cohen's d. Okay, and after that we can create the heat map by doing ggplot. We plot the grid. AES is x equal to n per group, y equal to Cohen's d, field equal to probability p less than 0.05, and tile scale field varidisk c name equal to probability of p less than 0.05, limits c01, label equal to function x, and paste round 100 times x and a percent. Label title equal to crossing, p less than 0.05 depends on sample size and effect size. Subtitle, target a larger samples or larger effect size make p less than 0.05 more likely. And then we get captions and also put the theme on it. And then we can print out. So on the right-hand side, you can see this heat map. Crossing p less than 0.05 depends on sample size and effect size. Okay. So basically, larger samples and larger effects makes p less than 0.05 more likely. You can see the more yellow, the higher the probability of p less than 0.05. If you look at, say, even with sample size, say 50, to the left of the x-axis closer to 0, for example, when the effect size become like 0.8, you still see yellow color, right? So you get very high probability to get p less than 0.05, even with a small sample size, okay? On the other hand, even with a small effect size like 0.2, when you get sample size 400, is also close to yellow or light green, which means high probability of p less than 0.05. Okay, so the take-home message is really you can make p less than 0.05 by keep increasing the sample size or the effect size. So that indicate the p less than 0.05 criteria is arbitrary, so and is problematic. So my view is we need to determine the cutoff value, the threshold for determining statistical significance according to the sample size and effect size. These three things are together, they're related. Okay, so cannot just arbitrarily assign 0.05 to determine statistical significance without considering effect size and sample size. All right, just try to make a point for you to get a better understanding about the p-value and how to determine statistical significance.